Welcome to The Explainer. Today, we're diving into the incredibly fast-moving world of autonomous vehicles. I mean, we've all seen the flashy headlines, right? But there is a massive leap between a car that just nudges your steering wheel on the highway and a true Level 4 automated vehicle, one that actually drives itself with zero human help in specific areas. So we're going to demystify the absolute maze of getting these highly advanced vehicles onto European roads. Okay, let's dive into this. Right off the bat, here's a wild contrast for you. If you head over to the US right now, you've got companies like Waymo running fully driverless robotaxis in places like Phoenix and San Francisco. Over in China, same story. Players like Baidu and Pony.ai have fleets operating constantly, totally driverless. But Europe? Despite literally being a titan in the global auto industry, Europe is essentially stuck at the starting line when it comes to commercial robotaxis. They've got effectively zero running continuously right now. So, what gives? What is holding them back? To figure out this massive lag, we're unpacking a brand new study from the journal European Transport Studies. This research comes straight out of the EU-funded MODI project. They went out and surveyed the top industry experts, car makers, and public road authorities to map out exactly what it takes to get AVs, automated vehicles, deployed in Europe. It's a fantastic deep dive into the very real physical and digital roadblocks standing in the way of our driverless future. So, Part 1, the global AV race. Let's look at how Europe stacks up against the US and China. The contrast here is just night and day. In the US and China, the whole philosophy is tech first and super localized. The US leans heavily on letting manufacturers self-certify so progressive states can just hand out permits and let the tech guys move fast. China is also sprinting, using localized legislation to quickly set up dedicated testing zones in specific municipalities. But Europe, well, they are taking a highly methodical, ultra-cautious approach. Like I said, zero continuously operating driverless AVs right now, mostly because they're hyper-focused on cross-border safety, harmonization, and making absolutely sure these cars perfectly sync up with the infrastructure. Now, to really grasp why infrastructure coordination is such a huge deal for Europe, we have to talk about one vital concept, ODD, or Operational Design Domain. Simply put, an automated vehicle doesn't just drive anywhere magically. It's built to work safely only inside a highly specific set of conditions. We're talking everything from crisp road markings to digital connectivity, and yeah, even the weather. If an AV steps 1 inch outside its ODD, it just cannot operate safely, period. Moving on to Part 2, Europe's regulatory hurdle. Let's explore this big European dilemma. Now, what's really interesting here is the regulatory maze each region uses. In the US, the manufacturer essentially self-certifies that their car meets federal standards, and then individual states handle the actual testing permits. It's totally streamlined for speed. China uses a national certification but gives local municipalities the power to fast-track testing. But Europe? They rely on incredibly complex international treaties, specifically UN type approvals. What that means is every single national authority has to give the green light. It creates this fragmented country-by-country headache for testing and liability. It is incredibly thorough for safety, sure, but man, it slows innovation to an absolute crawl. All right, Part 3, physical versus digital infrastructure. We really need to rethink what a road even is for an AV. Think about it. We have our physical infrastructure, the painted lane lines, the metal speed limit signs, maybe even dedicated AV lanes. The issue? Ripping up and perfectly maintaining physical roads across an entire continent is just ridiculously expensive for public authorities. But then you have digital infrastructure. We're talking satellite positioning, 5G networks, and high-definition maps. These are basically invisible tracks. And the real kicker here? Heavy rain or fog will completely blind a car's physical camera trying to see painted lines. But digital radar, 5G, and those HD maps, they power through regardless of the weather. There's this fantastic quote from an auto executive surveyed in the study that just hits the nail on the head. They said, "The machine, a robot, doesn't need lane marking. It needs a good map." We are so hardwired to build roads for human eyes, but machines process the world totally differently. These AVs are essentially acting like trains, but instead of steel rails, they are running on invisible, incredibly detailed digital tracks. Which brings us to Part 4, who paves the way? The absolute core tension right now is figuring out who actually pays for and builds these invisible tracks. If we look at the survey data, it shows just how lopsided this whole thing has been so far. Historically, a massive 67% of experts agree that the burden has fallen squarely on the car manufacturers. The tech companies have essentially had to build these insanely complex AI and sensor suites just to overcompensate for our existing, flawed, human-centric roads. Let's move forward and see how this builds, because a huge paradigm shift is happening. When asked about the future of level 4 driving, nearly half the experts, 49%, say it absolutely requires a true 50-50 partnership between private vehicle makers and public road authorities. The car companies literally cannot do it alone anymore. The public sector has got to step up and provide the digital and physical support these vehicles actually need. Part 5. 4 Recommendations for Europe. Let's look at the concrete steps Europe actually needs to take. So the experts boiled everything down into a 4-step actionable roadmap. Number 1, dual benefit infrastructure. Number 2, digitalize roads and rules. Number 3, integrate terrestrial and satellite networks. And number 4, standardize across borders. Let's quickly break down what these actually look like in practice. Recommendations 1 and 2 are honestly a huge sigh of relief for taxpayers. Public authorities are not going to have to bankrupt themselves building crazy robot-only lanes. Instead, they just need to focus on high-quality maintenance of what we already have, keeping signs clear and lane lines crisp. Why? Because those upgrades help human drivers and AVs at the exact same time. It's a win-win. On top of that, authorities need to digitize the roads by creating dynamic, constantly updated high-definition maps. It basically gives the AV a flawless digital memory of the road ahead, way before its physical cameras even spot a thing. Then we have recommendations 3 and 4, which tackle the big picture. Look, a self-driving car literally cannot afford to lose its internet connection, ever. So Europe has to merge ground-level 5G networks with low Earth orbit satellites, like the upcoming European IRIS-2 constellation. This hybrid setup guarantees rock-solid, resilient positioning using GNSS and real-time corrections. And finally, they absolutely must harmonize their laws. You can't have a self-driving truck hauling freight from Norway to Sweden and then suddenly stopping at the border because the digital rules changed. Ending these fragmented cross-border regulations is a non-negotiable survival requirement for the logistics industry. So we are truly standing at a fascinating crossroads in transportation history. As Europe meticulously paves its invisible tracks, it leaves all of us reflecting on the reality of human-machine coexistence on our highways. The ultimate question we have to face isn't just about the technology itself. It's about our world. Will we adapt our roads for the machines, or force the machines to adapt to us? Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.